Good afternoon, ladies and gentlemen. I would like to introduce myself. My name is Utari. I'm from Physics Study Program, Faculty of Mathematics and Natural Science, 11 Maret University. In this time, I would like to present our research entitled Effect of Synthesis Temperature on Structural and Magnetic Properties in Hematite Alpha Iron Trioxide Nanoparticle produced by Co-precipitation method. In the last decade, for introduction, in the last decades, the need for portable energy storage has grown enormously along with the development of mobile communication technology. Metal oxide of hematite in one possible material that owing to high density capacity, approximately 1,200 milliampere hours per gram, and then a simple synthesis procedure is the one of the reasons. And then modification of the order nano size particle can also be carried out through the synthesis parameter as well as doped by additional material. Several articles reporting the development of the hematite are modification in hematite nanorod was reported to increase the capacity rate. Nitrate hematite nanorods were reported to increase the battery capacitance. The increased capacitance for single crystal hematite anode materials as well as doped by reduced graphene oxide and nanoconformation of hematite. And then modification in the microdisc of hematite from 500 nanometer until 1000 nanometer diameter show good cycling stability. And then colloidal formation of micrometer order also change the capacitance of lithium-ion battery. Focus in our article is modification of nanosize order hematite through a synthesized temperature in the co-precipitation method. Material and methods. Material, iron, trinitrate nanohydrate, sodium hydroxide, alcohol, ethanol, and double distilled water. Methodology. All glass used for synthesis was first using an ultrasonic cleaner. Titration sodium hydroxide 4.8 molar with synthesized temperature 65 degree, 75 degree, 85 degree, and 95 degree Celsius. And then was the precipitate ethanol and distilled water. Hydrolysis with the 100 degrees Celsius for 12 hours, massing sample, and then annealing with 700 degrees Celsius for 4 hours, and then massing samples. Characterization. The crystalline structure of the sample were characterized using X-ray diffraction with the two theta angle is measured from 20 until 80 degree with the step size of 0.02, and then the hydrocarbon compounds as well as metal oxide contained in the samples were identified using Fourier transform infrared or FTIR spectroscopy with wave number 4000 anti 350 per centimeter, and then the magnetic properties were evaluated with the VSM. Result and discussion. Figure 1 is the XRD patterns of hematite nanoparticle with various synthesized temperature, and then the XRD parameter, there are crystallized size, lattice parameter, density, and microstrain present in table 1. From the figure 1 and the table, we can see that all diffraction peaks were indexed to the pure rhombohedral path of alpha iron trioxide match with ICDD number 89.0598, and then crystalline size increase with the increased synthesis temperature. The calculation result of the lattice parameter are consistent with the previously reported result. Strain decrease with increasing synthesized temperature. Figure 2 shows the FTIR spectra hematite nanoparticle with various synthesized temperature. Several absorption bands appear in all samples. The first absorption band around 3,411 per centimeter to 3,458 assigned as the stretching of oxygen and hydrogen bond, and the weak absorption band at 1,643 and 1,648. They are associated with the double carbon stretching double bond, and the bond appear around 1,430 and 1,050, yeah, associated with the oxygen and hydrogen bonding and carbon and oxygen stretching bonds. The two characteristic band around 534 until 530x and 440x until 455 per centimeter. They are assigned to the iron with oxygen bonds of the hematite nanoparticle. Then the figure 2, the hysteresis of loop of the hematite nanoparticle with various synthesized temperature. And the magnetic parameter of a hematite nanoparticle with various synthesized temperature present in the table 2. From this hysteresis loop and this table, we can get that the decrease of the coercive field is associated with the decrease of domain wall pinning in an interface, which also supports by decrease of remanence. The magnetocrystalline should attribute to the typical change of the coercive field and the saturation magnetization for the obtained sample of hematite nanoparticle. Conclusion. Hematite nanoparticle have been successfully prepared by co-precipitation method, and then the synthesis temperature seems to be to affect the structural and magnetic properties in the hematite nanoparticle. And XRD data confirm that the rhombohedral structure with space group R3C for all samples. The crystal size obtained was 23 until 29 nanometer. There are two main absorption bands around 534 and 448 per centimeter, which were confirmed as a characteristic of hematite nanoparticle. Meanwhile, the VSM analysis showed that the synthesis temperature is more dominant in changing the coercive field, indicated that the change of the nanostructural sample. This is our reference, and then thank you very much.